The integrated circuits on this breadboard are all identical 5x5 timers, yet they work in different ways or modes because of the way the other electronic components around them are connected. On the left hand side we have a bistable or flip-flop. Bi means two, so bistable means it's stable or happy to stay in two different states. If I press this switch here, it will come on. There's the light there. Press this one, it goes off. This one, it goes on again. In fact, it can remember which switch I pressed last. In this case it was the right hand one. Because it can remember, it's used as a memory element on its own, not much use, but elements like these are used in astronomical numbers in modern computers. The next one along, the next 5x5 timer, is wired as a monostable. Mono means one, which means it's only got one stable state. At the moment, this is the output light, its stable state is off. I can trigger it with this switch to come on, and it's set for about 5 seconds. Off it goes. The other useful thing about this monostable is there is a little infrared chip there, so if I can bring any TV remote control in, watch the little yellow light on the corner, press any key on the remote control, and that can trigger the monostable too. This circuit was used in our dancing flower models to great effect. The next one along, this third one, is called an A-stable. It hasn't got any stable states, it flip-flops between on, off all the time. This is quite slow, but we can change the speed readily, no problem at all. Now, linking from the output of the A-stable through this green link here across to this one, the last chip in this sequence is a NOT gate. Now, whatever the output on the A-stable is doing, this one is not the same. It's opposite, but we don't call it an opposite gate, we call it a NOT gate, and this is the simplest one of all. These components here, the resistor and the LED, are only there to show that it's working. To wire a NOT gate is ridiculously simple. You simply need to take a link from pin 2 across the chip to pin 6. That simple. In the next series of videos we will go through how to make each of these individual circuits in depth.